Hi, folks. Welcome to the Social Networks and Health didactic session being recorded for the SAMC Data Science and the Social and Behavioral Sciences program. The plan here is to talk a little bit about social networks and health. This will be a three-part introduction to networks as they pertain to health. The three parts allow you to skip around a little bit as you like. The first part and the last part, parts 1 and 3, will be largely about the health. Part 2 will be pretty much basic social network data stuff. This is an incomplete version, if you will, of the larger week-long session that myself, Lisa Keister, and Giovanna Merli do each year, our focused training in social networks and health, which is a grant funded by NICHD. And if you're really interested in learning into this a bit more and getting into the details, please look that up and reach out to us, and we'd be happy to show you how to get involved in that. The main difference between the two is that's a week-long session that will cover all the data coding and collecting and hands-on stuff. Here, you're really getting just the tip of the iceberg. You're going to get a lot of the what and a little bit of the why and almost none of the how. To ameliorate that a little bit, we will be posting some code and some example data sets on the SAMC site so that you can play a little bit with the R code for this to figure out how to do some of the basics that we're going to talk about here. But really, if you haven't done this kind of before and want to do more of it, please seek us out and we can get you hooked up with the larger process. The 3 points today, then, we're going to spend the first section, which is this piece, which will be largely on introduction and theory. Here we'll be talking about why is it that networks and health are linked? What is it about health that makes networks an interesting and intriguing thing to study? And we'll spend a fair amount of time talking about basic network theory. So what is it that makes networks relevant for social behavior and social outcomes? Part 2 is I'm calling it points and lines. This is the foundational basics of how data are organized for network analysis, and a little bit about visualization, and then a fair about network metrics. That is the things that we tend to measure on networks. So this is sort of like the network self-contained part. And then part 3 is going to be largely about network models. That is how we put these network elements in action in order to figure out a substantive question of importance. So that's the plan for today. I'm sorry you can't ask me questions as we go, but I'm pretty easy to find online. So if you're interested in engaging any questions about these things, please do reach out and let me know. And I'm happy to do my best to answer those questions. Let's start with Peter Blau. Why not? We always start with Peter Blau. To speak of social life, to speak of the association between people, they're associating in work and in play, in love and in war, to trade or to worship, to help or to hinder. It is in the social relations that men establish that their interests find expression and their desires become realized. I refer to this as the STRONG program in social network analysis. This is the ways in which we can imagine, what Peter Blau is saying here is that to be a human critter, to be a person, a who as opposed to a what, really means to be connected to other people, right? This is everything that we do in life that has any social meaning is coming from our connections to other people. And that's, why we care about social networks, right? Because what we're interested in understanding, except for a few very base biological things, depends on our understanding of how people are connected to each other. This is recognized formally for social network analysis with the work of Jacob Moreno in the 1930s. And I love this quote where he says, if we ever get to the point of charting a whole city or a whole nation, we would have a picture of a vast solar system of intangible structures powerfully influencing conduct as gravitation does in space. This is the promise of social network analysis, the idea that if we could just map these relations, we could exploit them and understand them and use them in ways that would help us understand the world in much the same way that we've put satellites into orbit now, or things like this, right? That if we could just understand what these invisible structures are, make the invisible visible, we could do better at preventing things like the spread of disease. I don't know that we've quite gotten there yet. I think we have part of this promise has been met. But that is the goal, like the long-term goal of social network analysis is to get us to a point where we can make sense of the world around us and exploit that sense to the betterment of social life and social well-being. A lot of people have jumped on this bandwagon, right? So if we just look at a plot of the number of papers published in social networks and health, you get something that looks a little bit like this. You see a pretty rapid increase since the 1990s. In this particular corpus, if you compare that to the number in the same search for obesity, you see that they're about comparable. That is that many people are studying social networks in health as they are obesity in health. And so that really, I think, gives you a good sense of the way in which this process has, this question and this understanding, or this way of thinking about the world has really caught the attention of health researchers. And for those that are interested in these sorts of things, it's also caught the interest of funders. So this is a similar plot looking at the number of grants and the amount of money that the NSF has spent on network analysis. So if you're interested in sort of hopping on this bandwagon, that's the goal, is just to point out that there are a lot of folks that are focusing on these ideas, and we want to give you the tools to get started and join in this field. To that end, it's worth building a little bit of intuition about what networks are and how they work. This is what you might imagine a high school looks like, right? So here are some classic high school sort of pictures, bricks and mortar and curricula and those sorts of things. When I think of high schools, I think they look like this, right? So this is what a network image of a high school looks like. And just to give you a little bit of sense of that, this is, went ahead here. Let's see if I can't get my pointer working. Right, so this is, you're going to see a fair amount of these kind of figures today. And so each point in this case is a child or an adolescent. A line is a friendship nomination from one adolescent to the next. Unlike a scatter plot, X and Y don't matter per se. Instead, what matters are proximity. So two nodes that are close to each other tend to be friends with each other or have friends in common. Two nodes that are far apart tend not to be friends with each other or tend not to have friends in common. Since it's a high school, it makes perfect sense to imagine what this is. I have the key hidden there. There we go. You can see that the colors here are related to the grade in school. And so schools and school friendships are, of course, organized by your grade. And so the junior high kids here are in this beige and purple. The high school kids are in the red, yellow, green, and blue colors. And you can see they're ordered somewhat by their grades. The 12th graders in yellow are further away from the freshmen and even further from the 7th graders, right? So this dimension here from northwest to southeast captures the grade set. This particular example is also organized by race. And so the east-west dimension here are white students on the left and black students on the right. And this is an emergent property of the way in which kids have made choices. There's nothing we've done sort of explicitly to force these into two clusters. That's just the self-organizing feature of these graphs, the idea that students tend to be friends with others of the same race and tend to avoid people who are not of their same race. So if you were to walk into high school of this, the lunchroom of this high school, you would probably find that white kids of the same grade are hanging out to each other, and you'd rarely find connections between kids who are junior high and high school in different races, for example. And I think this is a powerful testament of the ways in which these things tend to self-organize. And that's why we care about networks, is because this underlying structure, at least part of the reason why, these underlying structures create an opportunity for explaining the setting and explaining an element of context that you wouldn't necessarily get if all you knew was that this was a 50-50 split high school by race. And so it's once you understand that once you go in this school, the pattern of relation that breaks it into really separate communities, you might know something different then about the way these kids understand their situation and the way that they engage in schools. Social network analysis then is a set of tools designed to understand systematically these kinds of elements. And the goal of social network analysis is to take this structural motivation, and that's what that plot kind of is, right? Is that we have this this is a structure. It's an underlying social substrate that constrains the opportunities that kids are going to face. So the number of friends that I'm going to bump into, if a friend of a friend is a friend, then it's unlikely that if I'm a white kid, I'm going to bump into that many black kids that can be my friends. And so the idea is that the structural thinking here provides an underlying feature that relates the graph, this mathematical object of a network, to some kind of a social outcome via the ways in which this structure creates opportunities and constrains behavior. It's grounded in systematic empirical data, draws heavily on this graphical image. The graphical imagery is not sufficient for an understanding, but it's often necessary. I think it's the kind of thing that makes it possible for us to gain intuition about social settings that often you can't get any other way. And so there's a strong history for it. It also uses these mathematical and computational tools that are somewhat unfamiliar, I think, to a lot of social sciences. So we all grow up in the social sciences learning how to do basic statistical methods and probability, but graph theory is a little bit less often taught, and applied graph theory in this source, which is really what network analysis is is even less understood. So this is embodies a wide range of these kinds of ideas, and we hope to introduce some of those to you today. To give you just a hint of the way in which networks relate to health, I'll just point out the notion of a spillover effect. So we have this entire sort of field now of the social determinants of health. Networks are one of the social determinants of health, right? Just like taxes and laws and other sorts of opportunities in neighborhoods. Networks provide a context for behavior, but more than that, they create a conduit for spillover effects. So you can imagine that doctors provide healthcare to patients. Whatever that healthcare is, those patients might tell their social context, certainly their family, maybe also their close friends and neighbors. As an example, imagine the vaccine we're trying to roll out right now for COVID. If it's the case that patients have a really bad experience with that, they're going to tell that bad experience to their family and friends, and that's going to suppress people's willingness to get the vaccine. So we really want to make sure that this rollout goes well and goes smoothly so that we can capture the positive spillover effects and dampen the negative spillover effects, right? So that's the way in which we want to think about networks. That's one of the ways in which we think about networks. Now, this is a long and storied history of social networks in health. I like to break the field up into 3 periods, an early period that goes back to the 30s and 40s, sort of a formation, sort of internal organized period that occurs in the 60s and 70s, and then the modern period, which is largely the 80s and 90s, and particularly the 90s moving forward. We don't have time to go through all of this, right? It would be great to spend a whole bunch of time on this. If you're interested in more detail, let me know, and I can send you a paper that's underlying these sets of ideas. But I do want to give you a little bit of hint of this timeline, just to give you a sense of a series of what these papers are and a flavor for the kind of diversity of topics and the foundation of ideas that have driven social networks in health research. The starting place, or one of the starting places that you might think about this kind of work, is coming out of Everett Rogers' work on the diffusion of innovations. And what this piece really did nicely is set forth the ways in which we can imagine these classic logistic adoption curves. And the idea is that this is a contagion effect, that things start off small, a few people gain it, that gains recognition and visibility, and others jump on. And as that happens, you get this rapid growth, and then once you reach saturation, it kind of levels off. And thinking about the features of a community that lead to adoption really is fundamentally a network problem that's under the hood there. And that's one of the things that we're going to spend a lot of time thinking about when we get to the diffusion models. The other way in which this sort of the precursor to modern social networks in health is work on social support. And there was this great series of studies done by Berkman and colleagues that was looking at the ways in which your social support at one time affected mortality years later. And this is a fundamental piece because the data analysis made it possible to see this linkage really clearly. And it spurred a bunch of work, and you're going to see in a moment, so the work on social support and the ways in which social support affect health, lots of different ways that they affect health, has been a growth industry for some time. One of the other sort of main precursors to sort of modern social networks and health research is the work on HIV, AIDS, and sexual networks. It's not coincidental, I think, that networks and health research picked off about the same time that a big investment of energy and was put into understanding networks for work on the HIV epidemic. John Potteritt and Rich Rothenberg spent a lot of time in places like Colorado Springs doing really difficult data collection work, and that work spurred a bunch of data analysis work. Part of this was work done by Martina Morris and colleagues to look at the ways in which network timing matters. And a reason I put this up here is that it really helps focus and I think to some degree change the way we understand epidemiological models as network epidemiological models. And part of the key element here is that it's not sufficient to think about the ways in which people engage with each other just as a mass action. We need to understand the structure and the timing of relations if we want to make sense of the ways in which things spread through the network. This has been adopted, right? So there are lots of folks like Anderson and May that have taken some of these ideas up, and this is part of the same discussion that's been occurring about whether or not what element of detail you need, what element can we sort of push off to these max action models. Things like SIR curves and SEIR models have become pretty prominent now in the news given COVID over the last year. So this is more familiar than it would have been a couple of years ago, but these kinds of models fundamentally under the hood are abstractions from network processes. And so in order to understand networks and health, understanding diffusion over disease is the key process to that. Once you have this thing engaged, then you can think about diffusion, not just of something like disease, but diffusion of behaviors. And this is an idea that's gone on for a long time, or under the rubric of peer influence. And we think about a lot of this work has been done on things like smoking and drinking and other direct health behaviors, but also on attitudes and beliefs. And so there's been a bunch of work now on thinking about peer influence that is, some of it's been a little bit controversial, as we'll get to in a bit. The moderns sort of pushed that. So those pieces, I think, again, it was going through the 70s and 80s, through the HIV crisis. Then in the 90s, things really started to kick off. And so I'm only going to touch a small number of these. I want to point out some of Tom Valente's early work here. So Tom Valente spent a good deal of time translating the work of Martin Everett, Everett and Rogers, their work into a formal network model. And Tom has a series of, he has some software tools, he has a series of papers on these network interventions. He's modeled the flow and the spread of health adoptions and health behavior adoptions over time using these tools. And we're not going to be able to go into them in great detail when we get to later, but for those of you that are really interested in the ways in which things spread through populations or the ways in which you might intervene in networks, Tom Valente's work is the place you should start. So I strongly recommend going and picking up the Network Models of Diffusion's book. He has a second book called Social Networks and Health, both of which are fantastic, and I strongly encourage you to grab those and have a look at them. The other thing that happened about this time was a rapid increase in the availability of data. AdHealth is one example of this. This is the National Longitudinal Study of Adolescent Health. These data provided a collection of networks. And what this did, which was different, was made it possible for us to think about networks as a sample of a population of networks as opposed to case studies. Prior to studies like AdHealth and Prosper and a few others that have occurred over the years, networks were really a case study industry. And case studies are great, but it's really hard for policymakers to make policy based on a handful of case studies that are different in their methods and so forth. So having a single study that gave us a national sample of networks really spurred a rapid growth in the study of adolescent networks. And I think made it possible for people to be ripe for understanding samples of adult networks. And so you're getting more work on that front. But this also is, I put this here as a marker to think about things like the growth in the internet and the ways in which networks became available to study in the early 90s by the rise of the web and so forth. And that, of course, coincided with a series of tool development changes that occurred that allowed for the statistical analysis of networks. Prior to some of the work occurring in the mid and early 90s, and mid 2000s, excuse me, and late 90s, was networks were studied largely as descriptively. And so you would construct a metric on a network, and then you would talk about the distribution of that metric, or maybe use that metric to do something else. But it tended to not be an actual statistical model of the network. What the P-STAR work of Wasserman did, as then expanded by the StatNet team with Ergom's exponential random graph models, Carter Butts and Hancock, Hunter, Martina Morris, and Stephen Goodrow. This team built a set of tools that made it possible to treat the network itself as a dependent variable. And that's something that it was really kind of a game changer, because it changed the way in which we think about networks from this descriptive case study world to a collection of networks that we could model as something we wanted to explain statistically. And that opened, of course, the door to all of the statistical things that we want to do with networks. Substantively, there was a big sort of, this big paper by Christakis and Fowler sort of opened the floodgates to thinking about networks and health writ large. It'd been sort of a cottage industry prior to this, but this paper was pretty remarkable because it studied a problem that we cared about. The obesity epidemic was widely in the news. People cared about it a lot, and it was getting a lot of attention. And we were having a hard time explaining where it came from and what was driving it. And Christakis and Fowler found these data that covered 30 plus years of the same people and their social relations, and were able to show that there was a fairly strong correlation between a person's obesity and their peers' obesity. and the ways in which those changed over time. Now, this paper generated a ginormous amount of pushback, right? I'm not going to minimize that. But as a paper that makes it possible for thinking about these processes, it really opened the door. And we're going to dig into this paper in particular and some of the methodological questions that it raises as we go forward. Again, as this work has gone on, the other side of this is other sorts of online networks. And these, I vacillate on how much we want to think about social media as distinct from social networks, but there's clearly a connection there. And thinking about the ways in which we can exploit social media and network methods to understand social media is a growing and ripe field for exploitation. Now, this has been a very fast sort of overview of some key historical papers that I encourage you to go back and read, pull together and make sense of. But I also want to give you a little bit of a sense of the overall distribution of what this field looks like right now and just the sheer diversity of it. Because if you dig into a wider sort of set, and it's all of Web of Science, not just the social science side, or sorry, it was just this wider collection of papers. There have been something like 18,000 papers published in the last 20 years on these topics. And what I would like to do is just give you a sense of what all of those papers are about. And if you dig into the slides, you'll see a series of methods about how we get there. I'm going to skip over those right now and just say that when the end of the day, the thing that you end up with is this landscape. And the beauty of an intellectual landscape is it provides a spatial representation of a field of knowledge. And in this case, the field underlying this are these 20,000 papers on social networks and health. And those papers naturally jump into a cluster of content. So this is the set of papers, and the field is divided into these 32 big broad clusters, and there are subclusters within each of those, about 150 or so. So the big broad clusters are these topics like health policy or social support and aging, or whole works on different types of cancer, whereas the subfields tend to be much more focused features, things like breast cancer might be one, or alcoholism in adolescence or something. But the idea about this landscape is that it gives you a nice way of thinking about the sheer diversity of social networks and health, right? So it's everything from the study of, sort of epidemics and influenza to social support and so forth. And if you think about those keystone papers I just told you about, it's nice to think about like which of the papers underlying this set cite those papers. And that's what this plot shows you, right? So you can see that Rogers' diffusion of innovations has been studied across the entire sort of ecological set of these pieces. Same thing with something like Wasserman and Faust, which is a touchstone methods book, right? Something like Valente's work on either his work on the diffusion of innovations or his work on interventions, again, gets cited in lots of different places. Christakis and Fowler has been picked up mainly on this sort of social side of things, a little less on the health policy and health services side. But you see that it's really strongly cited in places that are working on social capital and so forth. Whereas something like Martina Morris's work on concurrency, that's a really important paper to a particular subfield. And so that's just a way of thinking about lots of these pieces. And I'm not going to spend a lot of time going through each of these, but I encourage you to go through and have a look and see what's there. What's also fun is that you can look at secondary features that might be covered in this field. So for example, there's been a spattering of work that looks at the ways in which social networks, race, and health intersect. And it's largely covered most of this field, right? It's not a deep amount of work, but it's broadly distributed. Whereas questions about gender networks and health tend to be almost entirely at the person level and almost never at the health policy systems level. So whereas we see some health policy systems work looking at things like structural racism that we're seeing sort of at that level about race, we don't see that same kind of work, at least nearly as strong for gender. On the other hand, we can sort of flip this and think a little bit about different types of diseases or social, health outcomes that we're interested in studying. And again, they're all over the place. So there's social support and aging work that's been done on BMI, and a similar work's been done. No, you can't see the. There we go. So the orange ones are BMI, the purple ones are about diabetes, the blue ones are about hypertension, right? So these are papers that are studied in those different kinds of things. The size of the circle in each of these cases, the number of times that paper itself has been cited. So you can see that there's lots of prominent work that's been studied in all of these areas. So again, this is probably a way too fast overview of the field of social networks and health. I strongly encourage you to pick up some of the pieces on this. If you want more detail, reach out to me and I can send you a paper that we have on the history of this field. Similarly, there's a great book by Tom Valente that goes through social networks and health with a more of an applied focus. I'm going to shift attention now. We're going to move on to an overview of network models and the ways in which networks, so we do network research. And I'm going to spend a little bit of time talking about two basic ways of approaching networks, this connectionist versus positional model that I like to think about. What I put up here is just to give you a sense of what the network research question flow works on. The key point is that we're not going to talk at all today in these series of lectures about data collection. So none of that's going to happen. And it's really, really important. Nothing else happens that doesn't flow from that. So before you jump in and do your own work, make sure you either go to our Social Networks and Health website and work on some of that work, or reach out to me and I can point you to some great sites on data collection, because getting the data collection right is key important. We're going to spend most of our time talking about scoring and explanation in part 2 and modeling in part 3. All right, so a couple of ways to think about networks. The first way to think about it is the distinction between variables and structures. Variables is the standard social science way of thinking about things that we want to explain, right? So if I can think about networks via centrality or popularity, a popular person might be healthier than an unpopular person. That's a network as variables approach. We take some element of the network, we boil it down to a characteristic of the person, and then we correlate that with their behavior and outcome. The alternative is a networks as structures approach. And a networks as structure approach tries to look at the big picture organization of the network and ask how that creates an opportunities or constrains the opportunities for healthy outcomes. So it might be the case that we ask questions about what generates hierarchy in social relations, and then ask questions, are hierarchical systems safer than non-hierarchical systems? Are things like self-harm more likely to occur in really hierarchical high schools or in low hierarchy high schools? I want to be a little bit careful about thinking of this as just macro and micro, and we'll get to a little bit of that later, but it falls along that a little bit. But the main goal is to think about, are you trying to describe a feature of the system or a person's involvement and embeddedness in the system, or something that really is about the person per se? These two ideas are then cross-cut by this notion of a connectionist approach versus a positional approach. A connectionist approach is a approach that deals mainly with networks as pipes. And this is by far the most common way of dealing with networks, right? Is that we think about networks matter because something diffuses through the network, either a resource or a disease or a behavior, right? Positional approaches in networks focus on networks as roles. The networks create this context that define who we are and how we should behave. And so the networks allow us to elucidate and make sense of what those roles are. I want to talk about each of these in turn in a moment. These are then cross-cut by your level of analysis. So an ego network or a respondent level of analysis is just an individual and their connections to those folks. And so we can think about lots of different models here. So a classic structural wholes model is a connectionist model at the local level. We're focusing on an individual and how they bridged other people. A complete network is really about the entire network, like everybody in a school or everybody in a town or everybody in a nation. It's this global structure. We might instead think about collections of networks. And so those can either be the same collection of networks on the same population. Those would be a multi-layer network. So we have kinship ties and friendship ties, or we might have 100 different schools that we're connecting. But in the same sense, we have this multiple network opportunity, which is something that we hadn't seen many times before. Thinking a little bit then about digging deeper into these two approaches, the connectionist network mechanism is probably the most intuitive. So again, the idea here is that networks matter because they're pipes through which things flow. And the obvious case here is disease diffusion, and in the time of COVID, it's hard to not have this at the forefront of your mind, right? So we know that the reason social distancing works is that we're trying to break the pipe. We're trying to make it impossible for you to connect someone else. But of course, anything that passes from a person to another person can be thought of this way. Everything from peer influence to rumors to the spread of misinformation online, right? All of these things are a diffusion process through the network. Now, a formal model for network diffusion is somewhat intuitive to help build some intuition. I think informative anyway to build some intuition about this. So, for example, we can think about this classic reproductive rate equation. And so here the idea is you have this thing R naught. R naught is the number of new infections that come from each index infection. And that's a function of the duration of contact, which is this beta idea, the likelihood that we connect to each other, which is C, and how often, how long you're infectious, right? So that's the D. And these things connected here should give you the expected number of new people that get infected for each person. For networks, what we really want to focus on is C, and this is this connectivity structure. We can think of that on the one hand as being an average, right? So what's the average probability that one person connects to each other? Or we can think about it as a structural feature, as a way where we map in the pattern of ties about who connects to who. To give you some intuition for that, considering something like a sexual network. So these are a sample of kids who have very high adolescents, who report romantic relations with others. And so here I've just given you a spattering of the sampled students in red and their two most recent romantic partners. And so if you treat them in this way, which was the classic sort of individual focused way of looking at HIV behavior, you can ask some questions that are useful. So you can ask questions about condom use or your type of sexual activity or frequency and so forth. And those kinds of individualized risk behaviors might tell you a little bit about who's at risk for getting diseases. But better would be knowing how those dyads are embedded in the global network where the disease is moving in this. So these are real data, of course. These are data from the Ad Health study. And these are romantic relations in one high school. And so these three kids, right, our focal student and their two most recent partners, are at a much different kind of risk than these three kids over here, where this focal person and their two partners are not connected to anyone else. That's because these three are in a chain with 288 other students in the same high school, whereas these three are not. And when I talk about network embeddedness, this is really what I mean, that our potential risk that we think people are engaged in has much more to do with where they fall in this structure than anything about the behaviors they engage in. And so when we think about a connectionist model for risk and disease diffusion or something like that, so we really are thinking about what is it about the network structure that's going to give us, is going to put a person at risk to the spread of a disease. And what's fun about this, of course, is that there are lots of questions you can ask about settings and a fair number of things that might not be intuitive. We're used to, in sort of general linear model world of networks as any kind of variable effect on outcomes, of thinking about sort of proportional changes. I move X a little bit, Y moves a little bit. That's what a beta coefficient does in a regression equation. It tells you that for each unit change in X, we get some expected change in Y. Networks tend to be highly nonlinear and not have that kind of outcome, particularly from this connectionist standpoint. As an example, consider something that we call about the overall connectivity in a network. And you can play these games with random graphs. Imagine you have a population, just to start off, where most people have one or two sexual partners, a few people have three. In this case, the average is 1.6, 1.68, and what you would end up if you were to generate a fake world with this kind of a distribution, you would see lots of little clusters, and each of those clusters would have lots of long, thin lines that would break really easily. That is, you wouldn't expect the disease to move through this network, because if anybody along these chains used a condom or didn't happen to pass the disease along, then no one downstream will get the disease. We can then imagine shifting the distribution a little bit, moving some of these people who have one ties to be people who have two ties, right? So we just shift people from 1 to 2. The average degree goes up from 1.6 to 1.7. You get a slightly greater connectivity. You can see where this is going. I shift from 1.7 to 1.8, 1.8 to 1.87, and now you get a much more connectivity. So a very small shift from 1.68 to 1.87 moves us from a disconnected world where nobody's really at risk to a highly reconnected world where there's lots of opportunities for reconnection and infection. These are the kinds of nonlinear emergent properties that come out of networks that are really easy to miss if you're not thinking about it in this kind of emergent properties structuralist sort of way. And that's what we hope to help you build some intuition for in the course of this studies. So connection approaches are by far the most common aspect of network models in health research. Theoretically, any feature of the setting that governs spread through the network is of interest, and it can be reflected at multiple levels. Often we don't have the exact trace for this. So often we don't have data on this, but it's the kind of thing that we can infer based on the pattern of spread that we see in the population. If we shift our opinion a little bit, we can think about positions on networks. And so positions are networks as roles. And I like to give this little example because I think it resonates, at least with Western audiences, right? So you can imagine that I give you a population of people in this little setting. Two of them share romantic love, and those two feed three others that fight with each other all the time. Right? This is, as you've probably already guessed, our classic sitcom family, right? We have a couple of parents, they love each other, and by virtue of being parents, they feed the kids, and the ungrateful little buggers are always fighting and having a good time with each other. So this is, of course, a caricature, but the idea is that it's an informative character. So we didn't need to know the labels, right, to know them, because we could infer them from the relations. And that's what the relational, sort of the positional approach to networks is really all about. And every social system is governed by sets of rules about how you interact with other people. And those sets of rules then shape the way in which you're going to behave. And we have empirical traces of those in social relations. The system of these relations defines an identity. That is, I'm not a balding professor of sociology, or I might be that. I'm also a mentor, a husband, a neighbor, a co-worker, right? All of these relations define who a person is, and they do so pretty uniquely. You don't have to get too deep into one's list of obligations and relations to find a pretty unique set that is your characteristic identity, right? The kind of person who is a who as opposed to a what. And that's a nice feature of the relational approach, or the positional approach to social network analysis, is that social life is conceived of here as a collection of roles. And those collection of roles are constrained. There are some things that by virtue of being one thing, you can't be the other simultaneously. You can't simultaneously be a parent and a lover to that same person, right? That's not allowed. That's a bad thing, right? And I throw out the nasty example just to really drive home. It's every system that has things like incest rules or taboo relations. And taboo relations are the things that give lie to the notion that you're free to do anything. Of course you're not, right? Social life constrains us, and those constraints are the very things that define systems of relations. And if we understand those systems of relations, we can use them to help sort of integrate health behaviors and understand where health behaviors came from. Role strain, for example, is the condition of occupying positions that really don't fit well together, right? Being a boss of someone and a spouse of someone simultaneously is a stressful position, and it's not a position we like to put people in. And so those are the kinds of things that you want to think about when you think about the ways in which a positional model might inform health. Right, there's a lot of sort of deep theory built into this. I'm not going to go into it in a whole lot of detail today, but I would encourage you to think about this process, right? That network tools allow us to empirically interrogate these ideas of structure and action that have really buggered social theory for some time. Now, one place that I think that it is ripe for a lot of this thinking, or at least illustrative of it, are the various and sundry ways that high schools create health outcomes. And so I'm going to just end this theoretical part by spending just a moment sort of teasing you with the ways in which the multiple ways these things intersect. So the connectionist view versus the positional view. So one thing we've known from all the work we've done on high schools over the last 40, 50 years is that high schools are characterized by hierarchical social systems. Now, the extent of hierarchy varies, the shapes of the hierarchy varies here and there, but they always have an ordered relations from bottom to top, and they have this sort of a rank cluster structure. So there are ranks in the hierarchy, and there are clusters across the hierarchy. And this is an example of data that we've collected in Prosper. And the most common relations we find in Prosper tend to be these kinds of hierarchies. That is, you tend to have a well-ordered set of relations between weakly connected cliques, and those cliques might have multiple branches in the hierarchy. The multiple branches are obvious from a high school standpoint because they're a young high school at this point. These are the first 4 waves. So your first 5 waves, excuse me, so you're seeing 6th graders here, right? So you tend to see boys and girls segregated. Now, these, if we then imagine sort of the social networks in health problem set in front of us, it really cross-cuts all of these different layers. And this is why high schools is such a fun context to study these problems in. So from a connectionist standpoint, we can look at direct ties, right? So we can ask, what is it that makes one kid to be friends with another kid? And how do we explain those direct friendship ties? And what do those ties generate from? Is it because of reciprocity, homophily, these types of things? We might instead ask questions about the global macro structure and what's driving hierarchy in these settings, and how do kids at the top of the hierarchy differ in their health and health behaviors than kids at the bottom of the hierarchy? Is there a role strain that's generated by virtue of being in the middle of a hierarchy? Right. This can get rolled up into classic types of positions, right? So we have something like a leading crowd, or sets of kids that everyone else looks up to and sets the normative behaviors for a school. That's something that's not really a diffusion process. It's really a modeling process, that by virtue of being in a leadership position, I have to engage in certain activities to show that I'm not a dupe of the teachers, but I'm still cool for the other kids, right? So this kind of a process would allow us to think about that. On the other hand, we can think about subgroups and the ways in which these subgroups create their own internal norms and beliefs about the way health and health behavior. And so we might explain that smoking is considered cool in one clique, but not in another. And so we can think about the ways in which communities generate micronorms, and those micronorms don't necessarily diffuse to the entire population, and why that might be the case. So again, this is the world's fastest treatment of social network theory. We could spend days on any of these elements. We don't have time to do that here. But I just wanted to whet your appetite to think a little bit about the ways in which the pattern of ties create opportunities and constraints for social behaviors that then later affect health. What we're going to do in the next set of slides is go over the actual ways in which we measure networks, the way we organize data, and then use those in the modeling section to explain health and outcome. I'll stop here. Hopefully you have a chance to take a break and that I haven't scared you off. And if not, I'll see you in part 2.